All right, so now in this video, we are going to learn how to compute a confidence interval to estimate a population mean, which we call mu. And we're going to use an example. Again, we're going to do 3 steps, just like with the population parameter. This one's a little bit easier, in my opinion. And let's go ahead and read through the example. We have a random sample of 117 observations, and it resulted in a mean, a sample mean of 26.3 from a population that is normally distributed, and that population has a standard deviation of sigma equals 4.31. Compute a 99% confidence interval for mu, and what is the margin of error? Okay, let's go ahead and do our 3 steps, starting with step 1. All right, step 1, we're going to identify n, the sample size, x bar, the sample mean, sigma, the standard deviation, all 3 of which are already given to us in the question. Then we're going to identify the critical z value, or z star, which we're going to do exactly the same as we did in the confidence interval for the proportion. Then we're going to identify the standard error. This formula is way easier than the one in the population proportion confidence interval. Okay, so let's identify our n. Let's see, n is 117. X bar is given to us. That's 26.3. Sigma also given to us. Over here is 4.31. All right, and now let's see how we're going to identify z star. All right, just like with the confidence interval and the population proportion, for z star we're going to go into numworks, we're going to go to distributions, then we're going to go to normal. We're going to make sure the mu is 0 and the standard deviation is 1. We're going to go to the two-tailed test, and then we're going to convert our confidence interval percentage into a decimal. And so here, 99%, we're going to convert that into 0.99. Then we're going to enter 0.99 in the far right box. And then what the middle numbers that we see, those are going to be our z star. Okay, so we'll put here z star. And then we'll go over to numworks and put in 0.99. So we're going to go to, in our numworks calculator, we're going to go down here to distributions. We're going to hit OK. Then we're going to go here to normal distribution. Mu is 0. Sigma, standard deviation, is 1. So we'll hit next. And then we're going to switch over to the two-tailed test. We want this one right here in the middle. Hit OK. And then we're going to go to the far right box. And this is where we're going to put in 0.99. 0.99, enter, and the number we need is right here. It's 2.575829. So 2.575829. Okay, now let's go to step 2. Or sorry, we need to identify the standard. All right, so now lastly, let's identify the standard error. All right, this is a really easy formula here. Standard error, very simply, is just going to be sigma, which we know, divided by the square root of n, which we know. Okay, so standard error is going to be sigma 4.31 divided by the square root of n, which is 117. So we're going to put 4.31 divided by the square root of 117 into the numworks calculator. So we'll go home, we'll go up to the calculator, and then we'll do, what is it, 4.31 divided by the square root of 117. Execute, and we're going to do this to 6 decimal places, 0.3984596. This 6 makes this 9 a 10. 10 means this 5 becomes a 6. So it's actually 0.39846. 39846. So standard error is going to be 0.39846. Okay? All right, that's it for step 1. Let's move on to step 2. All right, step 2, margin of error. It's exactly the same as with the population proportion. The margin of error is very simply z star times standard error. Okay, so the margin of error is going to be, well, let's put down here 2 2.575829 times standard error, which is 0.39846. Okay, so 2.575 829 times 0.39846, and our margin of error becomes 1.02636, and this 4 will become a 5 because of this 8. All right, 1.026365. 6365. Got our margin of error. Now let's move on to step 3. All right, here's step 3. It's very similar to what we've already seen in the population proportion. Identify the confidence interval for mu. Confidence interval for mu. We'll put mu in the middle with the less than or equal to symbols. So this whole thing will always be in every confidence interval. And on the left side, we're going to do x bar. That's called a point estimate. Our point estimate of mu is x bar, so it's 26.3. And we're going to subtract the margin of error, so minus this. And then over here, we're going to have x bars plus the margin of error. Okay, so over here, we're going to do x bar, which is 26.3 minus 1.026365. So 26.3 minus 1.026365. We're going to go to 3 decimal places here. So 25.274. So 25.274. Then we have the less than or equal to mu, less than or equal to, make this better here, less than or equal to, and now over here is where we're going to put x bar plus the margin of error. So if we go back here, we'll do 26.3 plus 1.026365, and we get 27.326. 27.326. So here is our confidence interval. Here is our margin of error, and we have answered the question. All right, let's do one more example. We got a random sample of 54 observations. That means n is 54. Resulted in a mean of x bar equals 88.4. So we'll note that over here. X bar equals 88.4. From a population with a normal distribution having a standard deviation of sigma equals 7.11. Put that over here. Sigma equals 7.11. Look, we're more than halfway done with step 1. Compute a 96% confidence interval for mu. What is the margin of error? Well, we're going to need the z star now, the critical z value, which we can get if we turn our 96% into 0.96. We will go over to the NumWorks calculator, normal distribution, home, distributions, okay. We'll come over here and put in 0.96, and we get 2.053749. So 0.053749. Is that right? Yep, 749. Okay. Now we just need our standard error. Which is just going to be sigma 7.11 divided by the square root of n. N is 54. So 7.11 divided by the square root of 54. So we'll go here. Got to go to the calculator. We'll do 7.11 divided by the square root of 54. We'll go to 6 decimal places here. 0.967. So 0.967. 548. 548. Okay, good. That's step 1. All right, step 2, we want the margin of error. The margin of error, here we go, is simply the z star times the standard error. So 2.053749 times 0.967. 3.7548. Okay, great. So 2.05, 3749 times 0.967, 548, and that gives us 1.987101. 1.987.101. Great. Now we're going to do our confidence interval, and we're done. Our confidence interval is going to be mu is less than or equal to, on both sides here. And on this side, we're going to do x bar 88.4. So do 88.4 minus the margin of error, which is 1.987.101. And over on this side, it's going to be the same thing, 88.4, but plus 1.987.101. We're going to round to 3 decimal places, mu. Okay, good. And so we'll do 88.4 minus 1.987.101. That's going to give us 86.413. 86.413. And then over on this side, we're going to do the same thing. Remember, I can actually arrow up to this previous calculation, hit OK, and now I'm going to change the minus into a plus and hit execute. We get 90.387. 90.387. And there's our confidence interval, and here's our margin of error, and so we are done. I hope this helps. I hope you have a better understanding of calculating a confidence interval for a mean.